Okay, it became obvious to me last period that I cannot keep going at the pace we are going. All right, with all this new vocabulary. So I have elected to take not a day off, but a day from new material today. Okay, which means I need to adjust all the homework and everything else. With that being said, if I'm giving you this day of no new material, we're taking advantage of it, and we're knowing this down cold coming in tomorrow. We're not waiting for Monday's quiz. All right, if I'm giving you this opportunity, a little day off from new material, we know what the lines that are concurrent are, what the point is they intersect, and what's so great about them. Okay, so I'm taking all today to go over that, answer all your homework questions, and then I'm going to show you the quiz is still going to be on, changing that. Okay, quiz is on Monday. It will cover all 4 special points and what we end up doing. We were supposed to do today, but now we will do tomorrow. So here is the breakdown, maybe. Okay, let's try this again. I do that. There we go. Okay, so tonight's homework, moving to Friday. Tonight's homework says partitions. Moving it to Friday. It is due on Monday before we take the quiz. Okay, everyone good with that? So tonight's homework, move it to tomorrow night where it says partitions. It's due on Monday. Tomorrow night's homework, move it to Tuesday. It's due the Monday after break. And then I guess you can just totally cross out Tuesday's homework because that'll be done after break sometime. Quiz will still be on Monday. Okay, so again, I work on partitions, moving it to tomorrow night, but I am checking it before the quiz on Monday. Friday night's homework, not on the quiz, move it to Tuesday, and it'll be due the Monday after break. Quiz is still on Monday. And up top here, that is your new assignment for tonight out of the textbook. All review, in center, centroid, circumcenter. All right, that top one is your new assignment for tonight, which is all completely review, should be anyway. So again, I'm taking this day off of new material. You're going to take advantage of it. I'm not asking you to, you're going to. And tomorrow we'll know all this stuff down cold. All right? Good? All good there. Okay. Here we go. You don't need to copy any of this down. You actually have this chart in your packet that you can fill in on your own to make sure you know what the heck is going on. All right? What I need you to do now, if you don't know the answer, you better be flipping through your packet, finding it, okay, if your number gets called. All right? But you basically have a blank chart in your packet, which I don't want you to fill out while we're doing this. I want you to try to do it on your own as you get ready for the quiz. Good? All right, so here we go. You got 4 choices now. Name any lines in a triangle that are always concurrent. All right, I will take anything. It does not have to go in any order. And obviously, most of you guys can just cheat right there because it's on the page. So I'm not even going to ask anybody. I'll start it. I know the medians are all concurrent from yesterday. I'm not going to go in order. First question I'm going to ask somebody as part of this review day. What is a median? What is a median? How could you draw a median, right? If I gave you a triangle right now, could you draw a median in with the correct markings? So that's what I'm asking you guys right now. What is a median? Explain to me what a median is. Here we go. 5, can you explain what a median is? Good. It has, there's the first part. It's got to come from a vertex. This right here will never be a median. It doesn't start at a vertex. Has to start at a vertex and keep going. Midpoint of the opposite side, so I'd expect markings that look like that. There's a median. Okay, everyone good on what a median is? We said yesterday there's 3 of them in every triangle. 3 of them, and they are concurrent. That point where they all meet, we called yesterday. What's the point they all meet? 3? Okay, you know, that's a great reason, Izzy. 2, what's the point where they all meet? It was the huge topic of yesterday and the homework. It's called the centroid. All right, good thing we're giving this day off here because tomorrow this thing's going to be filled in within 2 minutes, hopefully. All right, what's the special fact about the centroid? This was the big topic yesterday, and hopefully you applied it on your homework. 16, what's the big fact about a centroid? Divides median. Every median divides it into a ratio. 2 to 1. If you want to say 1 to 2, that's fine. You just got to know what the 2 part is and the 1 part. All right. So median, centroid, divides it up into 2 to 1. All good. All right, I'll go angle bisectors next. Because I know all the angle bisectors are concurrent. So if I had you guys construct using your compass all 3 angle bisectors, they'd intersect at this point. 6, they'd intersect at this point. In center. What's so special about it? What is so special? I found the in center. Now I know 2. What do I know now about the in center? Equidistant from the sides. Equidistant from the sides. Then we also, for day 1, we did, hey, the perpendicular bisectors of every side are concurrent. And a point called the, where do all of those intersect? Here you go, 23. Circumcenter. What's so special about that one? The circumcenter. What's so special about it? Boy, here we go. Let it go. This is good. 4. Vertices, yes. Okay, everyone good on those 3? Any questions? Because the 4th one I didn't get to at the end of class, and we're going to do it now. If you guys want to go to page in your packet, sorry, Dylan. If you guys want to go to page 9, we can finish those notes from yesterday. Yesterday, we talked about this new term called a median, which is from a vertice to the midpoint. And I also talked about this new term, altitude. So I'm going to ask somebody, describe to me what an altitude is now. An altitude in a triangle. Okay, you have a triangle. Describe to me what an altitude is. 2. Okay, let's stop there. It's got to be from a vertex, just like the median. Hey, I do this. Is that an altitude? No, I don't care that it's perpendicular. It doesn't start where? It's got to start at a vertice. All right, it's got to start at a vertice, and I know this isn't drawing the scale at all, and it's got to be perpendicular to the opposite side. All right, how many of them are in a triangle? How many of these could I draw right now? Only 3, 1 from each vertice. And you would notice that they are all concurrent. All right, at a point called the orthocenter. So you guys have a up top, number 9 on bottom of page 9. You guys have a little orthocenter for a definition. That's the point of concurrency for the what? Altitudes. Okay, that's what the orthocenter is. And at least this is some good news, I hope. There's no anything special about it. There's nothing special about it at all. Okay, nothing. I got nothing for you there. It's not equidistant from anything. It doesn't break it up into any ratio. I got nothing for you. Is that the one I wanted? There you go. I got nothing for you as far as the fact goes. Questions? I have one last question because I know this is a lot and I'm going to try to give you some advice here or there. Of all these concurrent lines, these 4, what is the only one up here that does not have to come from a vertex? There's only one up here that does not have to come from the vertex. The other 3 have to always come from a vertex. The only one that does not have to come from a vertex, Mike? Perpendicular bisectors do not have to come from a vertex. All right, they just have to split that other side in half and be perpendicular to it. The other 3, altitude, angle bisector, and median always have to start at a vertex. Always, always, always. Okay, you're good there. Keep on that page because we got to, I know there's no special fact about an orthocenter, but I need you to know where it's located. Okay. It says type of triangle, 3 types of triangles. Acute, you guys want to take the other 2 from here? If I start with acute, obtuse, I'm naming it by its angles, not its sides. Acute, obtuse, and what's the other one by its angles? Right triangle. And what I mean by the location of the orthocenter is inside, outside, where would it be located? Because it's not always inside. I can tell you that. It's not always inside. So I have an acute triangle, and you guys don't need to do this, but I have an acute triangle right here. What's an altitude again? Somebody remind me, what is an altitude again? Here we go, 18. What's an altitude again? Yep, it's got to start at a vertex and be what to the opposite side? This is huge. It's got to be perpendicular. So everyone ready? What I did here was I just did a quick acute triangle. So it's got to start at a vertex, perpendicular to the opposite side. Everyone good with my altitude there? It's got to start at a vertex, perpendicular to the opposite side. There's my altitude there. Where do you think this orthocenter is going to be in an acute triangle? It's got to be inside, right? There's no way it's going to be somewhere on the outside. All right, so for any acute triangle, the altitudes will always intersect inside the triangle. Inside. And I know most of you, that's hard to believe that it wouldn't intersect anywhere else. Well, let me go to my obtuse triangle right now. Here you go. Why is this, again, anybody, why is this obtuse triangle? One angle is over 90 right there. Okay, that's a little bigger than a 90-degree angle. All right, so here's my problem. Starts at a vertex. Why isn't that an altitude? Absolutely not perpendicular. All right. I don't care how many times I try to draw this. From this vertex, am I ever going to get an altitude inside the triangle? No, I got to draw it outside. That's the only altitude I can draw there from that vertex. I can extend this side a little bit, and that's the only altitude I can get. Meaning, I draw in the other 2 altitudes, or do all 3 are going to have to intersect? It's got to intersect somewhere here, right, on this one. So it's got to intersect somewhere outside. So the orthocenter for a obtuse triangle is somewhere on the outside. And what about my right triangle? This usually stirs up a little talk. I want to do a bigger one here. Ready? Altitude? Altitude. I don't have to draw it. It's already there. Where's the altitude going to be from this vertice? It's the leg. Everyone see that? Isn't it just the leg? So this is already an altitude. Ready? Let's go from, clean up this mess. Let's go from this vertice. Altitude. Altitude. Where is it? It's the other leg. It's perpendicular to the opposite side. I don't have to do it from this vertice. Where do these two altitudes intersect? Where's these two altitudes intersect, and where's my orthocenter going to be? Right there, isn't it? So there's where my orthocenter is going to. Does everyone see that? Because what's the definition of an orthocenter? Where the what intersect? Altitudes. Well, they already intersect there, so the third one's going to intersect there as well. So how can I describe for a right triangle where it'll be? How can you give me a description? If I have a right triangle, the orthocenter will be here. Instead of pointing to it, how can you describe where it is? There's 3 vertices, though. Where the legs intersect. Okay? So there's nothing special about it, but I still need you guys to know where it's located based on the type of triangle. All right? All right, now I want to go to homework and answer all your homework questions, and let's get this out of the way. Homework really dealt with centroids, medians and centroids on the homework. Medians and centroids. Where are we starting with you guys here? Where are we starting with the homework? Maya, what's up? 9? JT, yep, that's a good question. First thing, before I do answer that question, I will let you know in the givens it said ZT was 18. Okay? Can everyone see this all right? We all good? Because I'm going to start asking some questions here. And there goes ZT. First question, because I see all these beautiful hash marks. What is SV? What is ZT? And what is UY up here? Based on those markings and what we discussed yesterday, give me a vocabulary term for what these 3 line segments are. Sorry. All right, what are those 3 line segments based on those markings only? Because I don't have to come out and say, hey, they're these. You should know it by the markings. Here we go, 11. What are those? Okay, where's the perpendicular, though? That's going to be my argument. I don't see a right angle. Here we go, ready? Let's start basic. T. Those are congruent. What's T then? Okay, angle bisector, I need arc marks. What is it? Well, T's not a median, it's a what? These 2 on each side are congruent. T's right in the middle. Okay. Midpoint. Midpoint, we good? Right? Because, hey, that's a midpoint if each side's equal. Good, you're not off the hook yet. If I draw it from a vertice to there, what are these 3 now? Vertice to a midpoint. Median. These are all medians. Charlotte, we okay? We all good? Okay, everyone else good. They're all medians. Meaning they all intersect at what point up here? Don't name the point, just give me the letter. They all intersect at what letter up here? J. Give me the name for point J then. If those are medians that all intersect at J. What's point J? Here we go. 25. What's point J? We don't have one. Stopping my mojo. 6. What's point J called? Centroid. I'm trying to give you a thought process right now on how to deal with these problems. Those are medians. That makes J a centroid. What's so great about the centroid? 7. What's so great about the centroid? 2 to 1. Okay, now I'm going back to Maya's question because we're focused on ZT right now. Which is the bigger one, ZJ or JT? Which one's the bigger segment? ZJ. So if I call JTX, what are you calling ZJ? Don't say a word. 2. What am I going to call ZJ? 2x. It's double. That's where that 2 to 1 comes in. Everybody good? And in total, it equals 18. So I can say 2x plus x equals 18, and I'm off to the races. Good? Okay. Others we want to go over. This is your day here. Day to catch up because the train's not going to stop the rest of the unit. Go ahead, Marlies. What do you have? 24. 24. EC is an altitude. Everybody stop right there. EC is an altitude. What's going on? 8. What's going on if that's an altitude? So keep going. It forms A. If it's perpendicular, forms A. Right angle. So that tells me angles 1 and 2 must add to 90. We good? And that's exactly what they give us. 2x plus 7, 3x plus 13 adds to 90. Find x, plug it back into the problem. All right, everyone good. Altitude perpendicular to the opposite side. Perpendicular lines form a right angle, which equal 90 degrees. Okay, keep going. Keep grinding here with the questions. This is your time here. Go ahead, Naomi. 37. Did we have 37? I thought we just went up to 30. Okay. Oh, I may have just not have gotten rid of that one. What'd you try? 36 you were going to try? I know, all right. All right, I left it on there. I wouldn't have gave you 36. Maybe 37. Yeah, I took that off. I left it on the answer key. 2/3 of AP equals AD. All right, we can go over it real quick. Based on the figure, well, here we go. Come on. Luke and Kareem are arguing. Luke says that 2/3 of AP equals AD. All right, well, think about it. If I take 2/3 of AP, is it going to get bigger or smaller? Smaller, right? So it can't be, I'm getting bigger to get to AD. All right, so there's no way I could be taking 2/3 of AP and getting something bigger than it. Good? Now, if you said take 2/3, if I take the 2/3 and move it over here, then maybe we'd have an argument. You see why, though? Okay, if you take 2/3 of AP, it's going to get smaller, but AD is bigger than that. So, anything else? Going. Yes, Natalie. Number 18. Okay, what was it? Identify BD as an altitude, median, or perpendicular bisector. Okay, and I had all of them written down, I think, on the answer key. Okay, here's why. Make this even bigger. Okay, why is it an altitude? Starts at a vertex and is perpendicular to the opposite side. Why is it a median? Well, here's what's point D if I have markings on either side here. That's a midpoint, so it's also a median. And then why is it a perpendicular bisector? Well, it's perpendicular. And what's bisect mean again? Cuts the side in half. So you see altitude because it's perpendicular from a vertex. Median because it's from a vertex to a midpoint. And perpendicular bisector, because yes, it is perpendicular and bisects AC. So it's all three in that case. Okay, good. I guess the question should have been altitude, median, perpendicular bisector, or both. Even if you said one of them, at least I'm happy with that. If you said none, then I'm really concerned. Anything else here? Okay, so here's how I'm leaving it the rest of class here. You're knowing these things. All right, coming in tomorrow, we're knowing these things because this is it. No new vocab after today. All right, tomorrow, yes, it'll be on the quiz Monday, but it's, you know how we break a median up into 2 to 1, right? Is it possible to break a line segment up into 3 to 4, 2 to 3? And that's what we're going to be doing tomorrow. All right, breaking it up into different ratios than 2 to 1. All right, so you can either start the homework, start filling in the blank page on page 10, 11 in your, what's that page there, Dylan? On page 10, it's up to you. All right, you can get a textbook and start trying those new problems out. I will have an updated answer key on Aspen later on today. And I'm going to suggest that you do this on your own, sitting down by yourself, so you can actually think, do I know what's going on? Hurry up. Sign out and take the pass. Here, get those out of the way. Thank you. Let's go. If I'm giving you this time, let's go. Grab a book, sit down, go. Can you fill in that chart on your own now? That's the goal when you come in tomorrow.